Okay, I think I'm going to start. Can everybody hear me clearly? Thanks, Chiu. Right, so welcome to the first tutorial on Thursdays for Advanced Social Psychology and Judgment and Decision Making. I'm Kristy and I'm going to be leading this tutorial, and Chiu is going to be supporting me today. First things first, have you guys listened to Kit's tutorial? If you have, it's fine. If you haven't, it's fine. I just wanted to know. Nope. Okay. Anyone else? Yes. Okay. So if you've listened to Kit's tutorial and if there's something that you want me to address in more detail, do let me know when I get to the slides. Okay, so today we're going to cover two main things. So first, we're just going to go over housekeeping matters, and then I'll move on to talk about your registered replication report assessment task. So briefly introducing the tutors, I'm Kristy. I'm a new teaching assistant at the psychology department, and Chiu is an MPhil student supervised by Phoebe, who's interested in morality, judgment and decision making, and social cognition. And so for tutorials, we've currently got 5 sessions planned and maybe 6, depending on your needs. And as mentioned before, the first session is on housekeeping and the RR assessment overview. So if you have any questions, please contact us on Slack. I'm pretty sure I've already sent all of you an invitation, and yeah, just join Slack. And the links for your respective courses are right here, so do click on them if you haven't joined already. Do note that emails are only reserved for personal matters only, so things that only relate to you, and as listed here, so something like if you have complaints about your grades or group mates, or maybe somebody's free riding and submitting medical proof. We want you to post on Slack because we want you to share your questions openly so that others can answer or learn from the answers also. Okay, so about the tutorials, they will be online, recorded, and shared to the world. And for each session, it's around 2 hours. And as mentioned before, there's currently 5 planned. And the tutors will take turn demonstrating support. And as mentioned, Monday was Kit and with me supporting. Today is me and Chiu supporting. I think next week's Monday tutorials by Chiu and supported by Kit. And the one on Thursday would be led by Kit and supported by me. So please attend the session that you registered for. Sorry about my voice. I think it's because I drank coffee, really sorry. So do attend the session that you registered for, but feel free to join the others if you have any extra questions. And the key thing to note that tutorials are optional. We won't take attendance, but what we will be covering in tutorials would be quite important for your assessment tasks. So the RR assessment task is a team project, so the 4 of you will be working on it. And I posted the finalized groups yesterday on Moodle and Slack, and I hope you've already taken a look. If you have any questions about that, do post on Slack. And the RR assessment task is basically what we want you to do is to compare and evaluate the original article and the students or collaborators' pre-registration and registered replication report. And there are 3 key deadlines. So first is draft submission on September 24th on Sunday at 11:59. The second key deadline is the peer review on October 4th on Sunday, again at night, 11:59. And then the third and final submission is on October 11th, Sunday at 11:59. We will only mark the final submission, but it's not, you must submit a draft submission and peer review because these are important steps for you to improve for your final submission. So for our assessment task, you will have to have 3 key materials, a 4th one if it's available. So we want you to have the pre-registration of the original article if it's available, the original article, the pre-registration of the RR, and the final report of the RR. So why RR is important? I'm sure, as Feely has mentioned, there's currently a replication crisis. So it's important to revisit classic findings before working on novel studies built on the classics or real life application. So basically, it's kind of like back to basics or back to classics, because if the classics aren't actually what they are, what's the point of building on novel studies? And the RR things are done with like a pre-registration and a registered report with a clear plan, power analyses to reduce questionable research practices and degree of freedom. I'm sure those who took advanced social psychology saw from Feely's slides this week about the circular thing where a lot of red stuff is reduced if you do pre-registration and registered reports. So basically, the pre-registration, it's registering a study or a series of study with a timestamped record. And for a registered report, there's stage 1, where the introduction, method, and stimulated results are already done. And then you move on to peer review. And the second and final stage is where the real results and discussion are completed. So why registration? As you can see from this graph, in the traditional literature, there's a relatively low percentage of null findings. But for all registered reports and replication research and novel research, you can see there's quite a higher number of null findings. So this traditional literature could suggest like a publication bias that, suggests that it's very likely for an effect or phenomenon to be observed or likely to be true. But when it's registered, it suggests like it might be unlikely to find it, but it's still there, if that makes sense. Okay, for the template and structure of the RR, there are 5 key parts. So the first part is the abstract. The second part is the main body. The third part is coding. And the fourth part is comparing the pre-registration with the final manuscript. And the fifth one is comparing the original article with the replication. From part 2 onwards, there's going to be a checklist for you to go through, and I'm going to talk about them in depth in this tutorial. But do click on this link to check out the template and structure. I'm going to show you briefly for a bit, and if I remember correctly, it's made by Feely, Kit, and Chiu. So yes, do take a look when you have the time or after this tutorial, because this is the template you have to follow when you're writing it. This would be where the replication assessment starts here. So don't copy and paste the stuff here above. Okay, so here are the links for the examples from last year's students. I think there's 11 examples in total, so do check it out after the tutorial. And I'm going to go through a demonstration pretty quickly of from students' last year's report. And this is adapted from Kit's one on Monday, so if you've seen it before, it's pretty similar. Okay, so for this part, the students listed their name and the department and the university, and they also put in their university email and their personal email. Please provide your personal email because that's how we're going to contact you after you leave the university. And we also want the full details of the authors. So I'm sure as you've all done Feely's syllabus quiz, you should have all registered for a ResearchGate profile and OSF profile. If you haven't, I've probably emailed you to do that ASAP. And in this section, please put your full name and also your student ID, your institution emails, and personal emails also. If I'm going too fast, just pop it in the chat and I'll hopefully see it. And then you'll have to go through the contributor roles taxonomy. Please note that each student should have roughly equal contribution. Free writing is not allowed. If free writing does happen, please email Feely personally. And we also want you to provide important links and information to the original target article and RR with links. As you can see here, the student from last year did give the link to the original target article, but they left out the link to the RR. And we also want you to give us the OSF links for project content, such as the datasets and pre-registration. Okay, so this is where the main body of the RR starts. We want you to write an abstract. So do provide a brief description of the target original article on RR in terms of effects and results and the goals of the RR assessment. And do remember to give keywords because I think some of the students last year left out keywords. Okay, on to the original article bit. We want you to describe the original article's method. And a key thing to note is that we have a preference for tables over long text. And as you can see from this example, the students used a table to help summarize the measurements and the conditions. We want you to then describe what is the effect/phenomenon. So basically the relationship between the IV and DV. And then we want you to talk about the results. Again, tables over long text. We want you to then cover why it was important to replicate. So just basically the theoretical, academic, public, and societal impact of the effect or phenomenon. And then discuss why it would replicate. So possible reasons why the original article might replicate, for example, having a reasonable effect size, having transparency. And then discuss why it wouldn't replicate. So maybe there's a lack of transparency or reproducibility. And then for this bit, when you talk about the quality of target original article, we want you to do it for three things: the original target article, the RR pre-registration, and the RRR final report/manuscript. So for the quality, last year, the students assessed quality based on four things: the clarity, so whether the method and results are clearly reported, and transparency, are the method, results, and analysis files transparent? Reproducibility, does the article provide sufficient data and code for us to reanalyze and reproduce the results? And fourth, methods rigor, is the method well designed to assess the effect or phenomenon? This year, we want you to cover two extra things. The design, is it suitable for testing the hypothesis? And statistical power, please calculate the statistical power and conduct power analysis. If you're not sure about this part, Kit and Chiu will go over this for the second tutorial. Also, to note, when you're covering transparency in open science, do also provide the OSS links in your paragraph. Okay, moving on to the procedure. This bit is basically about how your group assessed the original article, pre-registration, and RR. So what files did you download, what did you assess, and what was your evaluation criteria based on? So the main findings is about the results of the original article and the RR. Do report or calculate the effect size and confidence intervals if available, but usually these aren't available in the original article. And do report the p-values. We also want you to cover the insights for the field and academia. So what is learned from the RR? How does it contribute to the social psychology field and the phenomenon or effect? And this bit is your key takeaways and what you have learned. So it's kind of like a mini reflection. So what have you learned from doing this assessment and how it would impact on maybe your replication extension assessment, or maybe how it will help with the thesis. So on to the third part, coding. So this bit is about whether the data is available and accessible, and how is it available, and is it downloadable and understandable. This part is pretty straightforward. I'm going to cover this in depth later in the slides. When you're talking about the reproducibility checks, we want you to answer whether the data and the results are reproducible, and whether we can rerun the analyses based on the provided data and script and find the same results as the original article. And the students provided a screenshot of the errors in your running analyses. So if you run into errors in running analyses, you should also provide a screenshot so we can see clearly what's wrong. And when you're classifying errors, there's an error classification scheme, and there are 4 main types. There's insufficient information error, minor numerical error, major numerical error, and decision error. I'll go in depth of these when I get back to the slides. Okay. When you're talking about the pre-registration assessment, there are 5 key things we want you to state and assess. So we want you to talk about the hypotheses, and then the inclusion and exclusion criteria, the power analysis, data collection design, and the data analyses, for example, the rigor, clarity, and specificity. So, on to the 4th main part. When you're comparing the replication pre-registration to final manuscript, do use Van Veer Al's table. This is the table, and I think it's in the slides also, so I'll also go over it when I get back to the slides. On to the 5th part of the main assessment, we want you to compare the original article to replication. So talk about the hypotheses, sample population, methods, and results. And you can compare the original article with the replication using Bront et al.'s replication recipe, and this is also available in the slides later. And then when you talk about the overall replications classification, you can classify it based on the Obels et al.'s 2018 criteria. And just a key thing to note that most of our replications were close or very close. And when you're evaluating the criteria for replication findings, use Obels et al.'s 2019 criteria. So we want you to evaluate the result outcomes in terms of the signal, consistency, and magnitude or direction by comparing the replication confidence intervals to original effect size. I'll give some examples later for this. Okay, on to everyone's favorite part, references. Please ensure that it's in line with APA style. Make sure it's hanging like this, not that, which is just wrong. And then do put the journal names, and the issue should be in italics, and do provide the DOI links. You can use Crossref to find the DOI links, so please don't exclude DOIs. Right, back to the main PowerPoint. So as mentioned before, the main body, there's, I think if I remember correctly, 11 things for checklist go through, as mentioned. So you have to talk about the effect or phenomenon. So you have to cover the method, relationship between IVs and DVs, the results, related theories and concepts, and also talk about why it's important to replicate. So for example, it might be because there's no or lack of direct replication, and then there might be theoretical and practical importance. Talk about cost-benefit decision analysis, enhance efficiency and reliability of science. Maybe there's mixed findings, or meta-analysis suggests a serious publication bias. Quick question, do all of you know what a meta-analysis is? If you don't, basically it's a quantitative synthesis of multiple studies of an effect and phenomenon, and it summarizes the main findings. So this is an example from another student group from last year by Chiu et al. And when they covered what is the effect and phenomenon, they clearly stated the relationship between the IVs and DVs, saying there's a causal link between subjective commitment in a relationship and forgiveness process after being betrayed. And then they went on to talk about the methods, highlighting that undergraduate students were recruited who were in a dating relationship. And they went on to describe that they were divided into 2 groups, and then asking about 12 hypothetical acts of betrayal, and responses were measured by 4 items. So the students also used a table to summarize things, and they talked about the related theories and our concepts, and they also talked about the measurements. But like as mentioned before in the previous slide, there were conditions, but they didn't talk about the conditions here. So to enhance clarity, it might be better if they used our template and also talked about the clarity. It's better to use this template, so it's on this link and on page 26. I'm not going to click on it because it's going to it will take too long for me to find a table for you right now. So on to continuing on with the example, the students then talked about the results of the experiments of the original article and the replication, and they said that the original supported the hypothesis, but the replication found no effect. This term, you should know that it's way too absolute. Please change it to say something like it failed to find support, because even an effect of 0.01 is still an effect, even though it's really, really small. So don't say no effect. And when the students talked about why it was important to replicate, they talked about expected utility and the cost-benefit analysis, and they also talked about context-dependent effects, and they evaluated the social cost. But it's better to mention more about the benefits of like why is it actually important for the field. So they then moved on to talk about the academic impact, theoretical, practical impact, and methodological concerns. So for academic impact, they highlighted that using Google Scholar search engine, they found that it's been cited a lot of times, especially for studies on interpersonal relationships. And for the theoretical and practical impact, they said the theory has been commonly used for educational purposes. And then they went on to elaborate that it's been used for social workers, and emphasizing on importance of trust and commitment. I think this is fine, but if you look at the example yourself, you'll see that the students left out references. So please include references when you're giving examples. And then they moved on to talk about methodological concerns, and they said that there was no effect size and power analysis of the article. So basically they said the reproducibility of the target article was questioned. So do check this when you're doing your assessment. So the other things that you have to cover in the main body is why it would replicate and why wouldn't it replicate. So it might replicate because there's published meta-analysis about it, or there's very, very good open science practices, or that it has high statistical power, or having realistic effect sizes. And it wouldn't replicate probably because of very unlikely effect sizes, or there's a lack of transparency or reproducibility, or the p-values are just falling just below 0.05, or that there's small samples, or there are failures / mixed findings with follow-up studies or conceptual replications, or there are like lots of statistical errors or just statistical errors in general. So an example from the same students, they said that it would replicate because it was supported by academic literature. Again, they went on to specify that there was 5 pages of literature and then gave examples of information, but again, they left out references, so please cite references. And actually, when you say it's supported by academic literature, it's good, but at the same time kind of vague. You should also consider things like conceptual replications or follow-up studies, and do also consider meta-analyses and open sciences practices. And they also said that it would replicate because it's supported by p-values. As Phoebe has mentioned in his lectures, this isn't a good reason why a study should replicate. So do keep that in mind. P-values falling below 0.05 does not mean it should replicate. So do consider about power and effect size. And again, the tutorial next week will talk about power and effect size. So why wouldn't it replicate? So the students highlighted that the original paper did not show the effect size, which is really good. And then they went on to calculate their own effect size, which is also good. But the key problem here is that they left out what type it was. It just said the effect size is of the study is 1.33. That doesn't really help. You should be very explicit in what type of effect size it is. So we think it's Cohen's d. So say something like, for example, you should say it like the Cohen's d of the phenomenon / effects is the effect size and the 95% site intervals. So do remember to report the effect size like this. And they went on to say that it wouldn't replicate because the variance, standard error, or confidence / credible of the measurement were not presented. So those are really good points because it's missing key stats. And then they went on to say that a small sample size is presented. So as I showed you in demo, we want you to cover the quality of the 3 articles, the original article, the pre-registration of the RR, and the final report of the RR. So basically for this checklist inside the main body, there's a mini sub-checklist also for it. So 6 points you have to cover: the clarity, transparency, open science, reproducibility, methods rigor, design, whether it's suitable for testing the hypotheses, and we want you to calculate the statistical power. So an example from last year's student from Chan et al. 2019, they went on to talk about the quality of the target original article. And before they went on to talk about the mini subsections, the students actually summarized their findings in a sentence or 2. That's also fine. So when they went on to cover the mini subsections, saying there's relatively low clarity for the target original article, they highlighted that there were ambiguities reported in the exclusion criteria and results, and that the authors didn't clarify why and how they carried out an independent sample t-test. And then they also found an inconsistency with the reported degrees of freedom. So do check the degrees of freedom when you're doing your quality checks. And they also mentioned that the data and code are not available. For transparency and open science, they went over the demographic structure, data, coding, and exclusion criteria, and they found that it wasn't available, and that they also found there was no data source file or data reproducibility checks. And they also highlighted that there's no reproducibility because data was not provided, so they were unable to reproduce the result. And then they went on to talk about the high quality design by saying that, oh, the design was improved by adding the non-dominant hand condition as a control to eliminate the confound. But please don't use the word eliminate. That's a bit too concrete or absolute. You can never actually eliminate anything. So it's better if the students actually use the word reduce here. The students also went on to talk about low power, saying the effect size was large and unreasonable with the Cohen's d of 0.82, and the sample size was small. Another thing to note is that this effect size is large, but it's not unreasonable. Cohen's d does have benchmarks, but it's relative and it depends on the context. So my key advice is never actually describe something as unreasonable. So they moved on to talk about the RR pre-registration, and they also again summarized the key findings in a couple of sentences at first, and then they went on to elaborate on it. So for high clarity, they said there was a clear report format and coding, and moderate level of transparency in open science because it was uploaded in Open Science Framework. And again, do provide the links to the files when you're talking about the quality. When they were talking about low reproducibility, they said that protocol and script are uploaded on the OSF, which is good. And they also said that a video recorded tutorials were provided. But one key thing that they also noted was that dummy data sets were not found. So yes, that would reduce the reproducibility of the RRR pre-registration. They then went on to say that the method's rigor was low because while there was a clear pre-registered plan for the methods section and protocols are available on OSF, and that there were experiment materials and user guideline for collaborating laboratories reference, only very brief details were provided, so it would definitely affect the adherence. So they also went on to say that the pre-registration RR has a less comprehensive design because the control condition, the non-dominant hand condition, was not included in the pre-registration, and that there was no other control condition introduced to address the possible confound. So please do pay a lot of attention to the methods. They went on to say that there was a high power because while the power analysis was not conducted in pre-registration, the students themselves conducted a power analysis and found an effect size of 0.82. And that a sample size of 80 is required to achieve 0.95 power, and 2,000 dummy variables, which is much more larger than 80, was used. While this is good that they conducted their own power analysis, they kind of used the wrong thing. You shouldn't use dummy variables to calculate power analysis. That's because dummy variables are categorical. It's usually used to indicate the absence or what's the word for it? Absence or having something. So for example, 1 for having a car, 0 for not having a car. So that does not work for power analysis. You have to use the sample size. They then moved on to talk about the RR final manuscript. And again, they summarized their findings saying it strictly adheres to the OSF policy and standardized the experimental procedure for which minimized the potential bias created from 7 contributing labs. That's great. And then they went on to highlight that there's low reproducibility because the raw data were not consistent without any justification from researchers. So when they were specifically addressing the subsections, they said that there was a high clarity because it's easy to locate the online resources, and there were specific links directing readers to the materials. And then there's high transparency in open science because there was a full data set, including all results regardless of the outcome on OSF. And they went on to say that there was low reproducibility because there was a detailed protocol, scripts, and analysis introduction. But in the end, the students failed to reproduce the result because of having wrong instructions in the guideline and having a different result as the reported one. The method's rigor was high because there was a clear and comprehensive methodology of how the leading laboratory and collaborating laboratories standardized the experimental procedures, which is good. They noted that. And that there were pre-recorded instructional videos, which limited potential bias for various laboratories across the world. And that it's also high because they consulted the original author to ensure accuracy in materials and procedures. If I remember correctly, Phoebe should be or has contacted the original authors for the RRs. Hopefully we'll hear back from them soon. And the students also noted that the design is same as the pre-registration because it followed the research design in the pre-registration. That's good. And they also noted that there was a high power because 1,894 participants were included compared with an 80% sample size. So still on the main body, we also want you to cover whether or not a replicate and how do you know. And we'll talk more about this in later slides using Libel et al.'s guidelines. And when you're covering if results differ, the 7 points, we want you to say which of the two do you find more convincing and why. Do note that usually it's the RRR that's often more convincing because there are more open science practices and higher statistical power. So we also want you to talk about what can be improved. For example, enhancing reproducibility and clarity of the data or code files, and increase transparency of method and materials, or maybe suggesting multi-lab or multicultural collaborations. And as I mentioned before, the lessons learned for your own replication, mini reflection time, the importance of the pre-registration, reproducibility of methods and data analyses, and importance of verification. So, another example from last year's students, the recommendations for improvement, they said the participants were students and then went on to suggest that they should recruit people of different age groups, education levels, and SES to obtain a higher darkness of population. That's a very reasonable suggestion. And then for what the lessons they've learned, they said that every conclusion should be grounded by different higher recognition standards or criteria and analyzed in terms of different aspects and method. And what they've learned, they said under open science, work is transparent and accessible to the public, and that it is difficult for research to make up fake data and mislead people. These are good points, but as mentioned before, better to mention possible transferable skills to replication extension project or maybe your thesis. So let's take a 5-minute break for now. All right, welcome back from the break. If you're back from the break, could you just indicate in the chat that you're here with me or not? I don't want to start without anybody listening. Awesome. Okay, so a student asked me if the lectures or tutorial will cover some of the basics of stats testing. Sorry to say that we've actually assumed that you have basic stats knowledge, but at least it's just knowing not about how they work, but how to conduct and interpret them. But if you would like to know more, I think Phoebe's going to cover more of it in his workshop, but that workshop also assumes basic stats knowledge. So it's up to you if you're going to join it. So on to the third main part of the assessment. You're going to have to go through coding. Yeah. So there's three mini parts for the coding bit. We want you to go through the pre-registration and coding protocol. And it's about the accessibility and availability of data and code with Obel et al. And Van Kep et al.'s criteria. And then second bit, you're going to have to do a reproducibility check with Hardwick et al.'s error classification scheme. And then we want you to talk about the pre-registration, the hypotheses, inclusion, exclusion criteria, pattern analysis, data collection, design, and data analyses. So using Obel et al.'s data accessibility and availability checklist, we want you to see if the article states whether or not the data are available. So it can be as simple as a link, URL link to a data file, or there might be an explanation as to why data cannot be shared or is shared. If you can't find it in the main body, sometimes it's in the supplementary material or acknowledgements or an appendix, or maybe it might be in the main body of the results. So when you found that, do choose one of the answers and elaborate. They're pretty straightforward. So according to statement, how are the data accessible? So do choose one, whether it's via URL or you need to request it upon the authors. And then if data is not provided, so choose the reason why it's not provided. Is it there's no reason at all, or is it because of legal issues, ethical issues, or practical issues, or something else? And if you selected one of the answers here, please provide additional details below. We'll also ask you, it will also ask you what does link lead to. Does it link to a personal web page, supplementary information, OSF, or a university repository, a third-party repository, or something else? And you also have to specify what the file format is. So in case of multiple files, please check all of that apply. So is it in a text file, or a comma-separated file, Excel file, SPSS file, data file, Word document, something else, or is it unclear? And do check if you are able to successfully download and open the data files. And as highlighted here, you must download the files to your computer and access to software for opening, or have access to the software for opening file. And then once you've downloaded and opened data files, do highlight which one it is. So you will also have to then go over whether data needed for evaluation and reproduction of the research appear to be available after a brief review. So you can choose if it's yes, all data appear to be available, or only some appear to be available, or no data in file, or it's unclear of all the data available. And do check whether the data are understandable after a brief review. You can do this by checking for additional documents. So for example, a code book or data dictionary to check whether it explains like the variable names. So for example, a variable might be named V1 and V2, and then they go on to explain what it actually stands for. So maybe like age or gender or something like that. And then we want you to then talk about the code or analysis scripts, code available download and analysis. Again, please ensure you have the right software to run the scripts or codes, so such as RStudio or SPSS. And do note that if the scripts or codes are available but not downloadable, choose no. So we also want you to check the data use license, whether a license is provided with the data. So either yes, it's a CC0 license, or it's a CC BY license, or no, a license is not provided, or other. So a CC0 license looks like this. And if I remember correctly, officially, it means that it's a public domain dedication where authors can distribute their things without restriction. Unofficially, as I like to put it, it basically means you can use their stuff without giving them credit. And for CC BY, officially, it's a permissive license. So you need attribution when you use the data. Unofficially, I know it as whenever you use the stuff, give them credit. Okay, so I'm going to go over an example briefly using the students' data from last year for this data accessibility and availability with Obels. So just give me a moment. Awesome. Can everybody see my Chrome? Great. Okay. So the first thing you have to go to is, does the article state whether or not the data are available? For this article, it's under the figures, if I remember correctly. Yep. It's here in this OSS link. So yes, it's a link to. So choose yes, the statement says the data is available. Do click on it. And then when according to statement, how the data is accessible by URL, that's fine. Then this website leads to OSF, so highlight that. And what is the file format? Do scroll down and check whether the files are actually available. And as you can see here, it's in the data zip file. Do download the zip file to open everything on your laptop, but I don't think I'm going to do that today. As you can see pretty briefly, all the files from all the laboratories are usually comma separated files, so do highlight that. And there's also a text file, if you noticed. And then according to students, all the data appear to be available, but I'm not going to download it today. So okay, after that, you have to check whether the data are understandable after a brief review. So as you can see here, it's pretty clear. There's also a codebook. Do click on that to check. And as you can see, it lists variables with v1, v2, which doesn't really explain anything. And then they do put a comprehensive description of what the variable actually means. Then moving on to analysis scripts and codes, pretty straightforward also. It's also in the zip file. Do download it. And once you open it, you can see that it's R, scripts for R. So do make sure you have R or RStudio to open and run these scripts. And to the data license use. Usually the data license use is right under the author names. So as I go up, it's right here, and you can see that it's a CC BY license. If I remember correctly, the students said there wasn't a license actually, but they're wrong. There's actually a CC BY license. So do click on the students' answers here if you want to take a look. It's from pre-20 to 21, and as mentioned, the last answer is incorrect because there's a CC BY license. So, using Hardwick et al.'s reproducibility check, the error classification scheme, we want you to check results and rerun the analyses with the data and code syntax analysis files if it's provided. And as mentioned, there are 4 types of error. So 1, insufficient information errors, which means it's ambiguous or absent, and you're unable to reanalyze it. And 2 is minor numerical error. It's where the percentage errors is less than 10. And 3, major numerical error, where the percentage errors is equal or greater than 10. So the percentage error is calculated by having the obtained number minus the reported divided by the reported times 100. And the 4th one is decision error. So whether there's error in the statistics used, reported, or interpretation of the results. And 2 key things to note when you're using Hardwick et al.'s error classification scheme. It's considered a failure if there's insufficient information error, major numerical error, or decision error. If there's only minor numerical error, please note that it's considered a success. So the students from last year, L 2019, they used the table to summarize it, which is good. And then they put the total counts for all of the errors. And they also highlighted how many of the labs actually had those errors. And for major numerical errors, you can see actually all of the labs had those kind of errors. So if you're doing this for assessment, you could also summarize it in a table if you want to, because as mentioned, tables over long text. They also put a table with the reproduced and reported effect size from all the labs. And as you can see, they actually do vary quite a bit for some. So it's a good way of showing that it's actually quite different from what we expected. So on to the pre-registration assessment part. Yes, 6 things to cover. So first, the hypotheses. Please list the hypotheses with a location, page number, direction, and number of tails for test of hypotheses. And for the inclusion and exclusion criteria, list the criteria and assess the specificity and interpretability of it. And 3, power analyses, please assess the reproducibility and accuracy, whether there were any issues or difficulties with it. And data collection, do talk about the availability of the number of target numbers or a range of participants, the time and method of data collection, and whether there's an alternative plan if the preset sample was not met. For design, do talk about whether it's experimental or non-experimental, whether there's a specification of randomization, and mention and description of blinding of experimenters. And the final bit for the pre-registration assessment bit here is data analysis, everybody's favorite part. So you'll have to talk about dealing with incomplete or missing data, what's their definition of incomplete/missing data, the procedure and method for checking for randomness, if they use Little's test or something like that, statistical assumption violations, did they violate normality, and outlier detection and handling, what is actually considered an outlier to them? Is it plus or minus the standard deviations from mean or something like that? What did they do with the outliers? Did they exclude it? Did they maybe like Windsorize it or something? And then we want you to talk about the reproducibility and calculation of measurement of variable. So there are composite and non-composite measures. So composite measures are several items or measurements, and a non-composite measure is just a single item. So do talk about the presence and absence and measurements of a non-manipulated IV for both composite and non-composite measures, and talk about the models and testing the hypotheses, reproducibility, availability of estimation technique, and computer standard errors. So maybe like for hypotheses, ANOVA, t-tests, stuff like that. And then do specify what software or program with the version number they used. Did they use Stata? Did they use R? Did they use SPSS? And was it like SPSS 15 or was it SES 14? And do specify the specification and producibility of inference criteria. So what was the alpha level? Did they adjust for multiple testing, such as using Bonferroni or maybe home CDAC? Okay, on to the second last parts of the assessment body. We want you to compare the design between the original article and RR, the findings between the original article and RR, and deviation between pre-registration and the final report. And there's also a fourth bit here, the data analysis verification. This will be covered in later tutorials, so don't worry about that for now. So do use Brown et al.'s comparison for design. So the components do cover the introduction, the instructions, the sample, the testing setting / location, the stimulus, materials, sample size, funnel section, and remuneration. As you can see from columns, it highlights the original article, the RR reasons for design differences, and there's a classification. For classification, you can choose from 3 categories. It's either exact, close, or different. I'm now going to show you an example from last year's student. And can you see what's missing from this table? So if you see, they covered the components, there's the original article and the RR, and then they went on to classification. So basically what they're missing here is the reasons for the difference. So do remember to put that include that in your assessment this year, because I think last year we didn't ask them to do reasons. If I remember correctly, for our RRs, there shouldn't be a lot of differences. Maybe for the remuneration, it should be different, and the participant population should be different, because I think we're recruiting using MTurk. Okay, so on to the Bell et al.'s replication design classification. As mentioned before, most of our replications are very close or close replications. And you should note that there may be slight changes or similar in design in some design facets. And if most design facets are same or similar, it's actually considered a very close replication. As you can see here, if the procedural details and physical settings are actually different, but the other design facets are same, it's considered a very close replication. So when you're comparing the results and result outcomes interpretation, there are 2 key things we want you to talk about: the effect size and confidence interval. As you can see here, we want you to say, explicitly state the effect size of the original article is, the confidence interval of the original effect is, the effect size of the replication is, the confidence interval of the replication effect size is. And then with the Bell et al., we'll go over in the next few slides. But when you're comparing, we want you to conclude whether the replication effect size is or is not significantly different from the original effect size. But a key thing to note here is that there may be multiple effect sizes due to maybe having more than one DV. And we want you to classify whether the replication is a success, an informative failure to replicate, a practical failure to replicate, or if it's considered inclusive. So if I remember correctly, a replication is considered a success if it's signal consistent, and it's an informative failure to replicate. It means that the original article might be a false positive, but we can never be 100% sure with this. It's considered a practical failure to replicate if there's differences due to differences in methodology or design, and it's inconclusive if the findings are mixed. So a really, really brief, tiny mini lecture on what is effect size. So the p-value is a probability of the probability of observed data given the assumption that the null hypothesis is true. And the effect size is the magnitude of the effects. For example, the difference between two groups, such as Cohen's d, the strength of a relationship using correlation coefficient R. So do report effect size because the APA 5th and 6th edition says it's almost always necessary. So basically, the magnitude of effect, it's easier to say if it's a big effect, it's actually easy to observe in a sense. If it's a small effect, you can only see it under really controlled and careful conditions. And mini lecture on confidence intervals. So confidence intervals are intervals for statistics such as means and effect size with a certain procedure. And in the long run, 95% of CIs will contain the true effect size that we want to know. So this example is made by Chiu. So if an example that you want to check the effectiveness of a medicine, and you repeat this experiment many, many times, you'll get varying effect sizes. So for each of the effect sizes, you calculate CI with a certain procedure. So for example, 95%, you'll get a lot of CIs. So roughly around 95% of the CIs will contain a true effect size, but we will never actually know. So a key thing to note is that the width of a CI is an indicator of the precision of your estimation if the other factors remain unchanged. The wider your CI is, the less precise it is. The narrower it is, it's more precise. Again, this is made by Chiu, so a simulated example. So imagine you want to estimate the mean IQ of the population. And we assume that the true IQ in the population is 100 with the standard deviation of 15. So you can see here, estimate the true mean IQ of the population is 100 in this line, and with the standard deviation of 15. So if you stimulate an example and run it 100 times, as you can see, out of the 100 times, the red ones don't touch the true mean IQ, and these are like around 5 of them. So you can say it's roughly 95% of the CIs do contain the true mean IQ. Okay, so talking about comparisons of results and the results outcome, when you're talking about signals, there are two criteria. So the first criteria A is when you have a signal detected in the original study. And criteria B is when there's no signal detected in the original study. I'll show you criteria A after I finish going through this slide. So basically, having a signal means that the CIs don't touch 0, don't include 0 or null. And it's considered a consistent if the confidence intervals include the original effect size. So this line. And as you can see, there are 7 replications. For the first replication, it's considered signal consistent because the confidence intervals don't touch this line or overlap it. And it's consistent because it overlaps the original effect size. For replication 2, it's signal inconsistent larger because, again, the CIs don't include 0, so signal, but it's inconsistent because it doesn't include the original effect size. And it's considered larger because, as you can see, it's more on the right side, the larger numbers of the effect size are, you can hear. And for replication 3, it's signal inconsistent smaller because, again, it doesn't include 0, and inconsistent because it doesn't include the effect size, original effect size. And it's smaller because overall, you can see from the scale below that the effect size is generally smaller. For replication 4, it's considered signal inconsistent opposite because it doesn't include 0, and inconsistent because it doesn't include the original effect size, and opposite because it goes to opposite direction. As you can see, the original one, it's positive, but for replication 4, it went into the negative direction. For replication 5, it's no signal and consistent because 1, it touches 0, and 2, it also includes the original effect size. So for replication 6, it's also no signal, inconsistent, because it doesn't include 0, and the CIs don't include the original effect size. And if you note, for replications number 7, there's no signal, and it's considered inconsistent, less precise. As you can see, the confidence intervals are way wider than the other ones and the original one. So for criteria B, it's about signal not being detected in original study. And then, as mentioned before, signal means that the CIs don't include 0, and consistent means that the CIs include the original effect size. So there are 5 replications here. For the first replication, it's no signal, consistent because it touches the null, and it includes the original effect size. For replication 2, it's no signal, consistent, and less precise because it touches the null and includes the original EF, but the confidence intervals are way larger compared to the original effect size. In replication 3, it's signal consistent because it includes the original EF and it doesn't touch the 0. For replication number 4, it's signal inconsistent, positive effect because 1, it doesn't touch null, and inconsistent because it doesn't include the original EF, and a positive effect because it's going in the positive direction. And for replication 5, it's signal inconsistent and negative effect because it doesn't touch the null, doesn't include the original EF, and it's going in the negative direction. So the main difference between criteria A and B is that A is for signal detected in the original study, B is signal not detected in the original study, and for B, if a signal is not detected, you have to, and it goes the other way around. So it falls in different way in between null, then you have to specify whether it's a positive effect or a negative effect. So an example by Chen et al. About did it replicate and how do you know? They said that it's judged as no signal inconsistent because the effect size of the replication includes 0, but excludes the original EF. And the replication found no effect. Again, as you can see here, please be explicit with what type of effect size it is. And please, please, please don't say there's no effect, because as mentioned before, even in a 0.01 effect size is still an effect. Do say that it found no support for the original hypotheses. So they went on to say the replication study found a signal, but it's inconsistent in the opposite direction because the effect size of the original study is blah, 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 which shows there was no cheating behavior more reminder. And then they went on to say the effect size of the replication study is 0.24, which does not cover this origin EF in the origin study. Okay, I'm gonna give you an example to try. So for example A, the original D is 0.7 and the lower confidence interval is 0.45 and the upper one is 0.95 with the p-value of less than 0.001. And the replication D is 1.05 with a lower bound of 0.9 and an upper bound of 1.2 with a 0.001 p-value. So what should be the interpretation of this? Do put your answers in the chat if you want to. Does anybody want to give it a try? Signal consistent. Okay. Anybody else? Signal inconsistent. Anybody else? Signal inconsistent. Okay. Anybody else? Signal inconsistent. Signal inconsistent. Yep. It should be signal inconsistent. And remember that we're using criteria A because there was an original signal found in the study. So it's signal inconsistent and larger. If we go back to the slides, so yes, signal inconsistent larger, because that one, signal because the CIs don't include 0 or null, and inconsistent because the CIs don't include the original effect size, and larger because you can see that overall the CIs of the effect size are relatively larger compared to the original one. Okay, for the second example, original D is 0.5, lower bound 0.2, upper CI bound 0.8, and a p-value less than 0.001. And replication D is 0.55, lower boundary 0.4, upper boundary 0.7, with the p-value less than 0.001. What should be the interpretation for this one? Signal consistent, consistent. Okay, anybody else? Okay, good. You guys got it correct. It's signal consistent. You're learning pretty quickly. Okay, for the last example, example C. Original D is 0.13, lower bound is negative 0.05, upper bound 0.31 with a p-value of 0.321. Replication D is 0.35, lower bound 0.424, and upper bound 0.46 with a p-value of 0.013. What should be the interpretation? Signal is consistent larger, okay. Whoops. Okay, Timmy said if you guys are paying attention to that, it's because whether an effect is smaller or larger is judged according to the point estimates. So in essence, the effect sizes, but not the interval estimates. Sorry if I got that wrong. Okay. Anybody else? Signal inconsistent, okay. Okay, so the answer is signal inconsistent larger because, as mentioned, we should use criteria B because the original article did not have the signal. So let me go back to the slides. Signal not detected in the original study. So signal inconsistent is right, but you do have to specify that it's a positive effect. Okay, so the common mistakes of using Lebel et al.'s interpretations. The effect of a replication is larger or smaller with a signal. The interpretation should be inconsistent. And a smaller or larger effects plus signal and in the same direction means that it's successful. And 3, if the original CIs include 0, use criteria B, not A. Okay, so when you're talking about deviation between the pre-registration and final report, it is completely fine to deviate from the pre-registration in the final report. And you should have like transparent reporting of deviation with justifications. And as mentioned before, please document the deviations with Van Veer et al.'s pre-registration planning and deviation documentation. That's the link for it. So do check it out later. Okay, so this is Van Veer's table. And as you can see, it covers quite a lot of things. So components in pre-registration, the study design, data collection procedures, stopping rules, manipulated variables, and all of that. And as you can see in this row, we want you to be specific, but brief at the same time. So when you're talking about the location of the pre-registered design and plan, rationale for decision plan, we want you to briefly state it and then give the location and link. And when you're talking about the deviations, just get on what type it was, just talk about whether it's a minor, major, and no deviation. And if there's a deviation, please give a brief description and a location and a link. And if there's actually a rationale for their deviation, do provide a brief description also and the location and the link. And when you're talking about how might the results be different if they had or had not deviated based on your assessment, please also provide a brief description, location, and link. And do state the date and time of deviation and stage if it's stated. And there's also a column for additional notes. So table notes. The location should include page numbers and sections and paragraph or line numbers. So basically be as specific as possible, because sometimes if you just give us the page number, there are quite a lot of paragraphs, so we don't actually know which exact paragraph we should be looking at. So do guide us there. And where possible, please embed an in-document hyperlinks to make browsing easier. And as mentioned, the categories for deviations. Minor is that the change probably did not affect results or interpretations, or major, that the change likely affected results or interpretations. So I'm going to show you an example from students from last year, HOA Al 2019, with the table. Right. As you can see, the students included the OSF links to here, and then they gave us the page number. But again, please be specific and give us the paragraph and maybe line number also. And what they did was good, but also, how should I put it? For rationale for deviation, if stated, they said that the rationale for each lab can be found at this link, this page number, but I think that's a bit too brief. So do be concise when you're explaining something, but not too brief to the point where you're just telling, oh, just look at that. Okay, so if you want to take a look later, do click on link and the tables on page 22 to 24. And for our assessment, as mentioned before, you can find other examples here in these links from last year's students. So do click on it if you have time or you want to use reference as a reference when you're doing your own RR assessment. So this year's project list. For those who watched KIT's pre-recording, that was before the groups and teams were finalized and before the add drop period was over. So this has been tentatively finalized right now. So it's from a syllabus. So page 19, you can click on here to check it for, this is for advanced social psychology. And for advanced social psychology, for section A, there's currently 5 articles. And for section B, there's currently 6 articles. And I listed some of the articles here. I'm not going to read them out loud. You guys can check it out in the syllabus. And I think I posted details on Slack yesterday night. For judgment and decision making, do check your own syllabus. It's also on page 19. And there are 4 articles for you guys for the RR. And also, again, I'm not going to read it out. I also posted on Slack about it, so you guys can check it out there. Okay, so for the expectations and page limitations for the RR assessment. For the main body, we want you to have less than or equal to 30 pages. And please do use 1.5 spacing and 11 times New Roman font. So as mentioned several times throughout the tutorial, please, we prefer summary or comparison tables and figures over long text. And please be short and concise, but comprehensive at the same time. And we don't have any limit on the appendices, abstracts, references, or any other added information. So do keep these things in mind. So work submission. Everything should be done in Google Docs from the very beginning. And when in Google Doc, make sure you have public viewing with commenting permissions, and it's accessible in incognito mode, not login, with full editing permissions to Phoebe. His email is this for the commenting permissions. And when you submit your work on Moodle, we want you to create an edit link, add the link to your document, then export that Google Doc into a Word file and submit it onto Moodle. So as mentioned, the second deadline for the RR assessment is on peer reviews. Phoebe's currently working on the RR peer review template. So when it's available, we will post it on Slack. And the aim of peer reviews is to help your peers improve by providing suggestions, and keep in mind what you would like a peer review on your materials to be like. So please be comprehensive, concise, constructive, and supportive. So do give specific examples where possible. And when you're reviewing, please be empathic and don't post snarky comments. I'm sure none of you would appreciate it if somebody talked about bad things or post snarky comments about your own work. It's actually very hurtful. So please be constructive. And we want you to appreciate and learn from the positive aspects. Okay, so now it's the Q&A section. So feel free to ask questions during this tutorial, or afterwards you can just post it on Slack. We may not know all the answers to all your questions, but we will try to learn and figure it out together. So we hope you will learn from the RR assessment, because it's transferable to a lot of things. So if you have any questions to ask, just post it in the chat. Okay, was anything unclear during the tutorial that you want me to go over again?
Sorry, I got a question.
Yeah.
Last night you have posted about the grouping and what article we have to do in the Airtable.
Yeah.
And in the Airtable, there is two articles. One is replication article and the other is RR. I want to know what that two article is used for. I'm a bit confused.
Okay, so for this tutorial, we're talking about the RR assessment. So on the Airtable, it shows up as the RR article you're supposed to do. For a replication article, it's another part of the coursework for the replication and extension assessment. I think that's after you've completed your RR assessments, if I remember correctly. So for right now, you can basically ignore the replication article for now.
Okay, thank you.
Anyone else has questions?
Hi, may I ask a question?
Yeah, go ahead.
Are we allowed to ask for feedbacks on the RR assessment before the final submission?
Sorry, I can't hear the latter half. You asked if you can ask for feedback for the RR assessment?
Yes, from the tutors before the final submissions.
Chiu, what do you think of that?
Can you hear me?
Okay, someone asked for the criteria as in assessing quality. Is it true that we have to find academical articles about that? Okay, before I answer that question, you're free to leave if you want. If you don't have any questions, I don't mind. Okay, for assessing quality, let's go back to those slides. Lighting, is this the bit you were talking about? Okay, let's see. Which part are you referring to? How to find academical articles about it? Let's see.
Maybe I talk.
Yeah, yeah, go
I
ahead.
think because there are a lot of criteria there, right? Like the quality of something, clarity, and how to note those. So we'll just refer to here about the criteria, or we need to find another academic article about this kind of criteria.
Oh, you can just refer to here. It should be on the template if you check it later. But yes, just refer to this. These quality indicators.
So there are questions on the template, and then we just answer those, right? Something like that.
Yeah. Let me show you the template. Yeah, it's just like this. So basically, for the quality, just address those things, then you're fine.
Okay, thank you.
You have given us the RR of article, but I don't see any link for the original article. Do we have to find ourselves? I should have announced on Slack the Airtable stuff, and I should have also put the links to the RR of your art. Oh, for the original article, yeah, you have to find it yourselves. Yeah, if you guys don't have any questions, feel free to leave. I really don't mind. Okay, someone asked me how you guys could contact your group mates, whether it would be via Slack. To be honest, we don't mind as long as you get your work done. So yeah, you could do it via Slack, DMs, or WhatsApp, whatever you prefer. But as long as if you have a question related to the course, just post it on Slack. All right. I'm going to end it now then.